This is the grade 11 lesson entitled Exponent Rules. So the learning goals for this lesson, we are learning to simplify exponential expressions using the following 3 rules. So we're going to learn 3 rules on how to simplify exponential expressions. The first rule is what happens when we're multiplying powers of the same base. The second rule is what happens when we divide powers of the same base, and the last is called what we do when we're multiplying or when we're simplifying an exponent that has an exponent or a power to a power. So the lesson that you should have should be 3.1 or another number, and it's going to look like this. If you don't have this sheet, please come get it from me. So if you've never worked with exponents before, what we're talking about when we talk about exponents are these little numbers here. So we've got 2 parts to this expression. We've got the base, which is the big number, and we've got the exponent, which is the small number. So what this exponent actually tells us is how many times we're going to multiply this big number by itself. So 8 to the power of 2 just means that we're going to multiply 8 by itself 2 times. So when we're simplifying it, it's going to look like 8 times 8. And when you put that into a calculator, that's just equal to 64. So let's try, we're going to go go in the opposite direction. So for number 1, it says to write each product as a power. So we can see that we're multiplying the number 6 by itself 2 times. So when we're writing this as a power, our big number is 6. That's our base. And 6 is being multiplied by itself 2 times, so I'm going to put a little 2. So 6 squared is the same as 6 times 6. Let's do the next one. So the next one, our base is going to be 7. 7 is being multiplied by itself 1, 2, 3 times, so our exponent is going to be to the power of 3. The next one, let's keep on going here. Okay, so what is the number that all of these numbers have in common? It's -2. So -2 is being multiplied by itself 1, 2, 3 times. So we're going to put a little 3. And the last one, we can do the exact same thing with fractions. So just because it's a fraction doesn't mean we can't make it into an exponent. So the base should be 1 over 4. And 1 over 4 is being multiplied by itself 1, 2, 3, 4 times. So this is the same thing as 1 over 4 to the power of 4. Let's go in the opposite direction now. So it says to evaluate each power. So our first one says 5 to the power of 3. So what that means is 5 is being multiplied by itself 3 times. So this is going to look like 5 times 5 times 5. So 3 times. And if you put that into the calculator, that just equals 125. So let's do the next one. I don't have a lot of room here. Okay, so this means that -3 is being multiplied by itself 2 times. So if you take a look at the next one, see, these look very similar, but there's a very important difference between them. So I'm going to go through this. So very quickly, what we're going to multiply by itself is whatever the exponent is touching. In this case, the exponent is touching the bracket. So this exponent is talking about everything inside the bracket. So we're going to multiply everything inside the bracket by itself 2 times. So what's inside the bracket? Negative and a 3. So we're going to multiply -3 by -3. And we know a negative and a negative, they make a positive. 3 times 3 is 9, so the answer is positive 9. Let's look at the next one here. What is that exponent 2 touching? The exponent is just touching the 3. It's just touching the 3, not the negative. So we're just going to multiply the 3 by itself 2 times, and we're going to stick this negative on the front. So it's going to look like this. We're just going to copy out, sorry that it's so small, we're just going to copy out the negative because it's not being affected by that 2 at all, and we're going to multiply 3 by itself, 3 times 3. So now this is -3 times positive 3. We know it's going to be a negative, and 3 times 3 is 9. So as you can see, these two look similar, but they have different answers, positive 9, negative 9. So what's most important to remember is just ask yourself, What is that exponent touching? In this case, the exponent was just touching the 3, so that's what we're going to multiply by itself 2 times. In the previous example, here, what is this 2 touching? Oops, sorry. What is this 2 touching? This 2 is touching the bracket, which means that everything inside the bracket must be multiplied by itself, and that's how we got positive 9. Let's go on the next ones. We can apply it to fractions, of course. So this is saying that we're going to multiply 1/2 by itself 3 times. So let's do that. We're going to do 1 over 2 times 1 over 2 times 1 over 2. And remember, when we're multiplying fractions, we multiply the top, then we multiply the bottom. So 1 times 1 times 1, we know that's just 1, over 2 times 2 times 2 is 8. 1 over 8 is the final answer. We're getting a little squished here. All right, let's do this last one now. So E says we've got negative 1 over 3 all to the power of 4. So what is that 4 touching? It's touching the bracket, which means everything inside the bracket we're going to multiply by itself 4 times. So that includes the negative. So when we do this one, it's going to look like this. Negative 1 over 3 times, whoops, can't get that 3, there we go. Negative 1 over 3 times negative 1 over 3 times, I'm running out of room here, negative 1 over 3. I'm going to rewrite this. Okay, there we go. So we're going to multiply these out. So remember, multiplying fractions, multiply the top, then multiply the bottom. So we've got negative 1 times negative 1 times negative 1 times negative 1. And we know that that has to be a positive. So we've got positive 1 over 3 times 3 times 3 times 3. Which is 81. So we've got the answer is 1 over 81. All right, if you think you've got this down pat, we are ready to go. We're going to look at rule number 1 of 3 that we're going to learn of simplifying exponents. So the first one here is multiplying. What happens when we multiply powers with the same base? So let's take a look at this first one. We've got to multiply 5 to the power of 2 times 5 to the power of 4. So if I was trying to figure this out, this 5 to the power of 2 means that I've got 2 5s multiplying by itself each other. So I'm going to start with 5 times 5. And then, you can put those in brackets if you want, we're multiplying against 5 to the power of 4, which we know is 5 multiplied by itself 4 times. So I'm going to do 5 times 5 times 5 times 5. So now it says number of factors. How many 5s do we have here? Well, we had 2 from here and 4 from here. So if we count them all up, we've got 1, 2, 3, 4, 5, 6 5s. So I'm going to put a 6 here. So if we were to write this all as a single power, it would be 5 6 times. So 5 to the power of 6. Let's do the next one. We've got 3 to the power of 5 times 3 to the power of 2. So let's do this one at a time. Let's do 3 to the power of 5. So that means we're going to write 3 5 times. So I'm going to try to write it really, really small. 3 times 3, 3 times 3 times 3. There's 5 times. And then we've got times 3 to the power of 2. So that's 3 2 times. 3 times 3. All right, so let's count up our 3s. We've got 1, 2, 3, 4, 5, 6, 7. So we've got 7 3s. So if we were to rewrite this whole thing as just one power, it would be 3 to the power of 7. Can you see the pattern already? We're looking for a pattern to get right from the question directly to the answer. Right from the question directly to the answer. Can you see the pattern? If you can, that's awesome. Let's see if it works for the next one. Okay, so we're going to do the very last one and then I'm going to tell you what the pattern is. We've got negative 2 to the power of 3 times negative 2 to the power of 2. So let's do negative 2 to the power of 3 first. We've got negative 2 times negative 2 times negative 2. Here we go. And then we're multiplying negative 2 to the power of 2, so that's 2 more times. Negative 2 times negative 2. Let's count them up. We've got 1, 2, 3, 4, 5. We have 5 negative 2s. Let's put it all together now. What is negative 2 multiplied by itself 5 times? That can just be simplified as negative 2 to the power of 5. So can you see the pattern? Here is the pattern. Take a look at these exponents in the first one, 2 and 4. The answer is 6. All we have to do is add the exponents and we're going to get to our simplified exponent. Let's check if it works for the next one. Our exponents are 5 and 2. If we add those up, we get 7. Woohoo, it's working. Let's do another one. We are going to take the exponents 3 and 2, and when you add them up, they're going to make 5. Beautiful. So we have a rule. We want shortcuts. Anytime that we can make a shortcut, we're going to do it. So the rule, when multiplying, and I'm going to underline that, when multiplying powers of the same base, what do we do with the exponents? We are going to add the exponents. Add the exponents. Okay, so anytime we see a problem that looks like this one, where we've got powers of the same base, 5, we're multiplying, all we have to do is add those exponents, and it's going to get us to the final answer. Okay, let's work on rule number 2. We've got 1 down, 2 more to go. So flip over the page. Here we go. Rule number 2 is what happens when you divide powers. Now you can already guess. If when we multiply powers, we add the exponents, guess what we're going to do from dividing powers? So let's check it out. Okay, so we'll just do a couple examples from here. I don't think we'll need to do all of them. So our first question is we've got 5 to the power of 6 divided by 5 to the power of 2. So we're going to make our own fraction. So I'm going to just put a little fraction bar in between here. And on the very top we have 5 to the power of 6. So I'm going to put 5 6 times. So I'm going to go 5, 5, 5, 5, 5, 5. Okay, so we've got 5 multiplied by itself 6 times. At the bottom we should have 5 multiplied by itself 2 times. So we've got 5 times 5. Okay, so now what we're going to do is we're going to cross out any 5s that undo each other. So for example, this 5 can undo this 5, so we're going to cross those 2 out. So I'm going to cross it, cross it. This 5 can undo this 5. So all we have left is 1, 2, 3, 4 5s. So number of factors left after dividing, we've got 4 left. So if we were to write 5 multiplied by itself 4 times as a single power, it would be 5 to the power of 4. Let's do the next one. I'm going to make a little fraction bar for us. Okay, and at the top we have 4 to the power of 7, so that's 4 7 times. Can we squish this into this little box? I think we can. So I'm going to write 4 times 4 times 4 times 4 times 4 times 4 times 4. We've got 1, 2, 3, 4, 5, 6, 7. There we go. And at the bottom we have 4 multiplied by itself 4 times. So we have 4 times 4 times 4 times 4. So we're going to cross out the 4s. That will undo each other. So we can cross out this 4 and this 4, 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 and we've got no more 4s to match. So now all we're left with is 1, 2, 3, 4. So the number of factors left after dividing, we've got 3. If we were to write this all as a single power, it would be 4 to the power of 3. So can you see the pattern? When we multiply powers, remember from the last rule, when you multiply powers of the same base, we add those exponents together. What did we do when we divided? Well, we started with 5 to the power of 6 over 5 to the power of 2 and ended with 5 to the power of 4. So we just subtracted 6 minus 2 and that made 4. Let's see if it works for the second one. Then we had 4 to the power of 7 divided by 4 and it made 4 to the power of 3. If we did 7 minus 4, that makes 3. We think we found our pattern. So let's write this down. So when dividing powers of the same base, which means that these 4s match, for example, or these 5s match, what are we going to do with those exponents? We are going to subtract. So when we're dividing, we are going to subtract the exponents. Okay, so we have those two down. When we are multiplying powers of the same base, like 2 and 4, or 5 to the power 2 times 5 to the power 4, add those exponents to get to our final answer. When we are dividing powers of the same base, like 5 to the power 6 and 5 to the power 2, subtract those exponents and we're going to get to the answer. So now let's do the very, very last one, which is when we have a power to a power. And what power to a power means that we've got an exponent to, or, well, I can't really see that. We've got an exponent and an exponent right beside each other. So here we've got 5 to the power of 3 all to the power of 2. So what that means is we're going to take 5 to the power of 3 and multiply that by itself 2 times. So let me erase this. Okay, so we've got 5 to the power of 3, which we know is just 5 3 times. And then we've got to multiply it by itself for a second time. So we are going to times 5 times 5 times 5. So we're doubling it. So how many 5s do we have? 1, 2, 3, 4, 5, 6. So we've got 6 5s. So if I were to write that all as one power, we've got 5 to the power of 6. We're always trying to look for that pattern, right? So we've got a 3 and a 2, and it made 6. So if you can already see the pattern in your head, that's awesome. Let's apply it to the next one. So next we've got 3 to the power of 2 all to the power of 4. So that means we've got 3 to the power of 2, which we know is 3 times 3. But we've got to do that 4 times. So we're going to do 3 times 3, 3 times 3, 3 times 3. Let's count up those 3's now. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got 8. So if we're going to put that all into one power, it's going to be 5 to the power of 8. Without doing the last example, can you see the pattern? You probably can. 3 and a 2, what do we have to do to make that 6? And 2 and a 4, what do we do to make that 8? If you said multiply those powers, you are correct. 3 times 2, that's going to make 6. And 2 times 4, that's going to make 8. So we have our pattern. So in words we have when simplifying a power to a power, what did we do with those exponents? We multiplied them. Multiply the exponents. Okay, so now will be the ultimate test. We're going to apply these 3 rules. So do you think you can remember them? The first one, multiplying powers. When we are multiplying powers, so looking like this, what did we do with those 2 and 4? We added them to make 6. Okay, so when multiplying powers, add them together to find our new exponent, or simplified exponent. Let's go up to dividing powers. When we divided, what did we do with this 6 and 2? We subtracted to make 4. So when dividing powers, we subtract the exponents. And last but not least, when we've got a power to a power, so 3 to the power of 2, what did we do with those 2? We multiplied them to make 6. So it's okay if you don't have them memorized yet. You will, but time we practice it for our quiz. So now let's apply these rules to, we've got I think 7 questions here. So let's work on the first one quickly. So the nice thing is we've only got, oh, something skipped in the recording, so I apologize if this is repeating myself. But we have the question 6 to the power of 2 times 6 to the power of 3. So if we've got it, since we've got a times here, if we remember, that must be rule number 1. Rule number 1 says when we multiply powers of the same base, we have to add the exponents. So let's do that. So we have 6 to the power of 2 times 6 to the power of 3. It's just going to be 6 to the power of, we're going to add those exponents, 2 plus 3, which is going to be 6 to the power of 5. Done. 6 to the power of 5. Okay, let's do the next one here. We've got 7 to the power of 5 divided by 7 to the power of 2. Which rule was that? Can you remember? It was rule number 2. Here we go. When dividing powers of the same base, subtract those exponents. All right, let's do it. So 7 to the power of 5 over 7 to the power of 2 should be 7 to the power of 5 minus 2, which is 7 to the power of 3. And you don't need to go further than that. Don't worry about putting 7 to the power of 3 into your calculator. As long as it's a single positive power, we're good. Okay, and the next one, we've got 3 to the power of 4 all to the power of 3. So we don't have multiplication or division happening here. We have a power to a power. So what was that rule? It's right here. When simplifying power to a power, we multiply those exponents. So we should have 3 to the power of 4 times 3, which is going to be 3 to the power of 12. All done. Let's go to the next one. Remember, whichever one I could possibly give you, there's only 3 rules that are available. One is when we multiply powers, another is when we divide, and the last is when we have a power to a power. I do not see a power to a power happening here, so we know that that's not what it is. I don't see any division symbols. Division symbols would look like this or the fraction bar. So I don't have that, which means I probably have multiplication. Because what's happening in between those two brackets? It's multiplication. It's just not there. But if we don't see anything, it's multiplication. Okay, so we know we're multiplying. I see 1 power here. I see no power here. What does that mean? Well, what that means is that it must be an invisible 1. So I'm going to put an invisible 1 there. So let's write this out. Our base is whichever these numbers have in common. So it's -3. That's what's going to be repeating. We've got -3 to the power of 4 plus 1, which is -3 to the power of 5. And then we're done. Okay, so now for E, what I want to do is I want to look to this fraction here. So we've got division happening. That's what that little line means. So we can only divide these two and simplify it if they've got the same base. So we've got a 1 up here and a 2 up here. So these bases do not match. So we cannot subtract the invisible 1 that's here from the 3 because we don't have the same base. So there's nothing that we can do inside of these brackets. So all that we're left to do is to take this 2 on the outside and distribute it into the top and distribute it into the bottom. So what that's going to look like is this. We're going to have 1 to the power of 2, so we're going to apply the 2 to the top of the fraction, and we're going to distribute it to the bottom of the fraction too. So we're going to have 2 to the power of 3 all to the power of 2. So we've taken this 2 to the top and to the bottom. So let's simplify it a little bit more. 1 to the power of 2 is just 1 times 1. We know that's just 1. We've got 2 to the power of 3 all to the power of 2. What do we do when we have a power to a power? Go back and check. We multiply those powers. That's our third rule. So we should have 2 to the power of 3 times 2, which is 6. And we are done. So when you are looking, when you have a problem that looks like this, always look on the inside of the brackets first. Is there anything we can simplify? We can't because we have different bases here. We've got a 1 and a 2. So the only thing we have left to do is distribute this 2 to the top and to the bottom. And that's what we did to finish off with 2 to the power of 6. We have 3 more examples and then we're done. Okay, so let's take a look at F. I want to see, can you figure this one on your own? We've got a fraction here, they match. We've got multiplication. So what would you do in 3a? Well, 3a was obvious. We've got to add those exponents because we've got multiplication. Just because we've got a fraction here doesn't mean that we do anything different. We're going to, as long as the bases match, which they do, and we've got multiplication, we're going to add those exponents. So let's pick our base. Our base, what's the number that matches in both cases? -2 over 3. We've got -2. Here we go. And we've got multiplication, so we know we are going to add those exponents. So we're going to do 3 plus 6, and that's going to equal negative 2 over 3 to the power of 9. And we're all done. Okay, 2 more to go. G, taking a look at G. So we've got brackets and an exponent inside of those brackets. So I want to try to work inside the brackets first. So let's just forget about that 2 at first. Is there anything we can do inside those brackets? Definitely, because we've got division happening, and both the bases matches, 8 and 8. So let's work inside the brackets first. So I'm going to continue those brackets here. We've got 8 to the power of 8, all divided by 8 to the power of 2. So our common base is 8. And then what we're going to do inside is we're going to subtract 8 minus 2. And 8 minus 2 is just 6. So I'm going to make this a 6. And then we've also got the 2 on the outside here. So now what we have is a power to a power. So we've got 6 to the power of 2. And we know that that's rule number 3. All we're going to do is multiply those out. So what we're left with is going to be 8 to the power of 6 times 2, which is 12. And then we're done. Let's work on the last one now. The last one, we've got something similar. We've got brackets and then a power on the outside of the brackets, this 4. So let's work on the inside of the brackets first, and then we'll simplify the 4 after. So we've got our common base is negative 2 over 3, negative 2 over 3. We've got multiplication happening. So we know we're just going to add these exponents 3 and 6. So let's do that. So we're working on the inside of these brackets first. So our common base is going to be negative 2 over 3. And then it's going to be all to the exponent 3 plus 6, because when you multiply, you add. So 3 plus 6 is just 9. And then we have, don't forget, we've got all to the power of 4. Don't forget about that 4. So now we can deal with the 4s, the 4 and the 9. So we've got 9 to the power of 4. We know what to do with a power to a power. We just multiply. So our base is going to be negative 2 over 3 to the power of 9 times 4, which is 36. And we are done. So on the back of your page, you should have a worksheet. What I'd like you to do is try some of the questions from that worksheet and let me know if you have any problems. If you can do the problems on the worksheet, you know that you know what you're doing. So just as a reminder what we learned in this lesson, go back to our learning goals. We're going to check off what you know that you understand. We are simplifying exponential expressions. We know exponential has a little number like a 2, using the following 3 rules. Multiplying powers, remember what we add the exponents. Dividing powers, remember we subtract the exponents. And last, power to a power, where we multiply. So go ahead and practice to make sure you understand it. If you have any questions, please come and find me.